If you took your laptop to Mars, it wouldn't even turn on. And if, by some miracle, it did, it would freeze within minutes. And yet NASA has been sending computers to Mars for decades, machines that must function continuously for years in conditions that would destroy regular electronics almost instantly. At night, surface temperatures on Mars can drop to -125 degrees Celsius. That's far below the operational range of any commercial-grade electronics. Most laptops stop working around -20 degrees Celsius. Below -40 degrees Celsius, many components shut down or suffer permanent damage. But temperature is just one part of the problem. Mars has no global magnetic field and no thick atmosphere, which means that onboard computers are directly exposed to cosmic radiation and solar particles. High-energy protons, electrons, and gamma rays can flip bits in memory, corrupt instructions, or even physically degrade microchips over time. So how do Mars rovers keep working? NASA's Curiosity and Perseverance rovers both use a radiation-hardened single-board computer based on the RAD-750 processor, developed by BAE Systems. The RAD-750 itself is a PowerPC 750-based CPU, originally designed in the 1990s, but extensively modified to withstand radiation in space. It's built on 250nm silicon on insulator technology and can survive doses of up to 1 million rads. The full single-board computer used in these rovers includes a CPU running at around 200 MHz, 256 megabytes of DRAM, 2 gigabytes of flash memory, and system-level components like watchdog timers and fault protection. It's slow by modern standards, but it's built for survivability, not speed. Each unit costs between $200,000 and $300,000, not for performance, but for reliability. But what about the cold? The rover's computer doesn't actually run in the open Martian air. The main electronics are enclosed in a thermally controlled, insulated compartment, and heat comes from two main sources: the electronics themselves and the rover's radioisotope thermoelectric generator, which not only provides power, but also passive heat. The interior temperature must be kept above freezing, or critical components, like batteries, solder joints, and capacitors, could fail. Additionally, electric heaters and thermal control software are used to keep the system within operational limits. Even that isn't enough. That's why critical subsystems are duplicated or triplicated. Curiosity has two identical RAD-750 computers. In 2013, the primary computer suffered a flash memory fault, and the rover switched itself over to the backup and continued its mission. You can't fix anything on Mars. There's no reset button, no second chance. Every byte has to work the first time, and then keep working, in extreme cold, under radiation, with no sleep. That's why the Mars rover's computer isn't a performance monster. It's a masterpiece of survival engineering. If you enjoy real tech stories like this one, backed by facts, not hype, consider subscribing to TechFacts.